let's begin. So, we have for you guys a new booklet, and this is for the rest of this term, Sam. So there's lots of notes in here, and there's lots of exam questions as well that sort of show us and point to the kind of content that they can ask you in the exam. So this is going to take us through calculus, so differential calculus, which is our first test, which is only on chapter 2 from the textbook. Okay, that's going to be our test, probably about week 7. And then applications of calculus, which is all of chapter 3, and that is the content of our second test. Our first test, we don't have a calculator and you don't have handwritten notes, okay? But you will have the formula sheet on the back here. All right, so this formula sheet you will be able to take into the test with you. So let's do a quick recap of what first principles is. So I'm just going to describe the information that's given to you at the front there. The purpose of first principles is to find the instantaneous rate of change of a curve. Okay? So firstly, let's remember the average rate of change, the AROC, and the instantaneous rate of change, and the difference between those. I always describe the distance between them in terms of your speed while you're travelling to Adelaide. Okay, so if you're driving along to Adelaide, you pass through Kiki, they take a photo of your car at Kiki. There's the average speed camera safety zone. They'll take a photo of your car, and then later on down the track, as you get towards Tailem Bend, they take another photo of your car. So they've got 2 photos of your car at different points in time, and they say, what's your average speed over that interval? Okay, that's the average. And as long as it doesn't exceed the speed limit, you're fine. You won't get a fine. All right? That's your average rate of change. But along that journey, your speed is probably fluctuating. Okay, you're probably, if you don't have cruise control, you're probably fanging it in different parts and then sort of easing back in different parts. It's very hard to maintain the same speed without cruise control, especially if there's some good tunes playing. So sometimes you might accidentally get up to 120, 130, okay, and then maybe at other periods you were looking in the back seat and you shouldn't have been, and you slowed down. So your instantaneous rate of change can change a fair bit. Okay, so average between 2 points. Instantaneous occurring at an exact point. So if we wanted to know the instantaneous rate of change of this curve, that means how steep is it at this point? All right. One thing we could do is draw a tangent. So a tangent is a line that is parallel to this curve, and the slope of this line, if we could calculate it, would be a good indication of the slope of the curve at that point. The slope of the curve at that point and the tangent have the same steepness. So we could calculate that to give us a good indication. But that's always subject to error, and it's fairly difficult to get right. So there's actually some clever maths that we can perform. All right? We can see, let's keep in mind, I want the slope at point A, and up here is point B. As I move B closer and closer and closer to point A, the slope of what we call a chord AB, is going to get closer and closer and closer to the slope at point A. All right? And so if we keep moving B so that it's pretty much next to A, okay? Let's call that AB prime. AB prime is going to be a better indication of the slope than AB would be. All right? So, that's what we're doing in first principles. We're saying, let's imagine that we're at point A and it has coordinates x and f of x. All right? They're the coordinates of point A. It has some x value and some y value. And then point B, we're going to say is really, really close to point A. In fact, it has coordinates x plus h, where x is approaching 0. Okay? It's not 0, but it's really, really, really close to 0. So it's x plus h, and that means the y value is f of x plus h. Okay? Now the slope of AB prime is going to be f of x plus h. Take f of x, on top of x plus h, take x. And that's where we get the formula for first principles that we've used before. plus h take x, just simplifies to h. Okay? That's the formula for first principles. Now, let's point out as well the table. Okay? So in the table there, we have the function where we have f of x and y, and we have the derivative function, f dash of x and dy on dx. F of x, putting x in will tell you the y value. F dash of x, putting x in will tell you the slope. Okay, let's get into it. First problem here, f of x is x squared take 2x plus 4. Part A, find the average rate of change from x is 1 to x is 3. Alright, so we're going to do y2 take y1 on x2 take x1. So we're going when x is 1, f of 1 or f of x will be 1 squared take 2 plus 4. And minus 1. Right? So we've got that y value. When x is 1, f of x is 3, the y value is 3. And so that means we have, that's our first coordinate, 1 and 3. Okay, to find our next coordinate, we're investigating when x is 3. We find f of 3. So if we find f of 3, we've got 3 and 7. So when x is 3, y is 7. When x is 1, y is 3. And now to find the slope between those 2 points, the average rate of change will just be y2 take y1 on x2 take x1. The average rate of change is 2. Over that interval, as x goes across 1, y goes up 2 on average. Okay, so when we're going to solve these first principles problems, the process is always the same. And I've put it out there in numbered steps. Okay? Step 1 is input into the first principles formula. Here's the first principles formula. So that means the things we need are f of x plus h and f of x. If it helps, list them. Here's the function we started with. And so f of x plus h is the function I get when I substitute x plus h everywhere there's an x. Okay, you can see the link from those two. And then we can plug both of those into the formula. So do that if it's going to help you. So step 1, put it in the formula. Okay, so very clearly I've put f of x plus h in brackets. Here's f of x plus h, take away f of x all on top of h. That's step 1, input into the formula. Step 2, fully expand and collect like terms. Okay, so in our next step we're going to perform all of these expansions. Alright, so we can see the negative out the front of f of x is distributing in there, it's applying to all of those terms. That's why we must put it in brackets. Alright, let's use a multicolour to show that we can go along and cancel some of these like terms. So we have x squared and minus x squared. We have minus 2x and plus 2x, and plus 4 and minus 4. All of those are cancelling. All right? So then let's write what we have left over. Okay, and so one of the diagnostics, troubleshooting we can use to make sure we're on the right path is that once we've cancelled everything, every term that remains has a h in it. Okay, we can see there's a h there, there's a h there, and there's a h there. All right, that means we've done the right thing. Otherwise, it means there's a mistake back a few steps. Okay, so at this step, we should have everything with a h in it. We're going to cancel the h. We're going to factorise it and cancel it. So this is what we're doing. Okay, I can pull h out the front. It's a product at the top and at the bottom, and it can cancel. Okay, so let's following that process again. With step 3, factorise and cancel h, that's done. On to our last step, step 4, apply the limit. And what you're effectively doing, mathematically here, is substituting 0 for the h. So if we put a 0 there, we are left with 2x take 2. Now notice how in every step I'm maintaining the limit throughout until I apply the limit. Okay, so the limit has been applied, and therefore I don't need to write it. Okay, you must include the limit every step of the way. Excellent. Okay, so that's part B. Part C. Find the instantaneous rate of change at x is 2. Alright, so over here in part A we found the average rate of change. Now we're asked for the instantaneous rate of change. If we look at our table, alright, that's what f dash of x tells you, the slope at a point. That is the instantaneous rate of change. So we are asked to find f dash of 2. When x is 2, what is the slope? What is the instantaneous rate of change? That means we're taking the number 2 and we're putting it into the f dash of x function. We're going to have 2 times 2 take 2. Alright, f dash of x is 2x take 2. We're substituting the number 2 for x into the slope function. And we'll have 4 take 2, which is 2. Alright, so that was part C. Okay, part D says explain the difference between A and C. So if we look at part A, our answer was 2. Alright? And if we look at part C, our answer was 2. They have the same value, but there's a difference between them. This is the average rate of change. It's occurring over an interval. This is the instantaneous rate of change, and it's occurring at 1 instant on the curve. Okay, so we can describe that in those kinds of words. That's part D. So it's just A is average rate of change over interval. C is at an instant. Okay, for part E I'll come here, I think. So we can finish off this one. Any questions so far? Part E, find f of 4 and f dash of 4 and explain the difference between them. F of 4 means we put the number 4 into the f of x function. Alright, here it is. 4 squared, take 2 times 4 plus 4. Okay, that's f of 4. What does this mean? When x is 4, y is 12. We've found a coordinate, 4, 12. Okay, let's find f dash of 4. All right, here's the f dash of x function. 2x take 2. What does it mean? This is the slope. Okay, so to answer, when x is 4, y is 12. That's a coordinate. That's a point on the Cartesian plane that lies on the curve. And the slope is 6. That's how steep it is at that point. Okay, so f of 4 tells us the y value when x is 4. F dash of 4 tells us the slope, the gradient, the steepness, the instantaneous rate of change at that point. Okay, wonderful. Let's turn the page. For the rest of the lesson, we're just going to be doing first principles problems. Okay, so we're going to be repeating this process here. All right. So here is an opportunity for you to attempt this one by yourselves. Okay, so for 2A, I'll give you guys the opportunity to have a go at it following this process here. Okay, so write it out. Write out f of x, write out f of x plus h, substitute it into the formula and have a go. I will write an answer up in a second. Then we will go through B and C together because they can both be quite tricky. Okay, so for the time being, have a quick go at 2A. Okay, excellent work, everybody. So let's talk about this one, and then we're going to do the square root one together. Okay. So believe it or not, the ones we've just done, the two that we've done are examples of easy first principles problems, okay, for year 12, all right? So they will escalate in complexity. I've seen all of you guys have all got a good grasp of this. That's fantastic. That means we're ready to start making them a little bit more complex, as we're going to do in a moment. Okay, a couple of things to point out here. When you substitute it into the formula, make sure we put them both in brackets, but if you put this second one in brackets, then the negative will always distribute to every term. Okay, that's the first piece of advice. The second is we need to be careful with this expansion, all right, because there's a square and there's a 2 that needs to go through. And for me, like we do bed maths, so we need to do the square first, we need to expand it first. But even for me as a maths teacher, I would never do both at the same time. And the reason is it's so easy to make an error going from there to there, to forget the 2. And so what you should do is it's worth taking the time to do it in 2 steps. Okay, you can see I've left the 2 out the front, I've just done the square, and then I've multiplied the 2 through. It will take a little bit longer, but it's better to take longer and get it right than to stuff up and then have to rub it out and try again and not figure out what the error is, and then sort of get a bit panicked about that. Okay, so I encourage you to do that, but you do what suits for you. And then the rest is fine. Okay, so let's do this square root one together then. Alright, so we've got root x is the function, and f of x plus h is going to be the square root of x plus h. And so if we're going to write this out in the formula, alright, excellent. And then it's like, now what? Where do I collect like terms? How do I simplify this? And so this is where it escalates a bit. We need to do some clever manipulation. So this is a general rule for any first principles involving square roots. Okay, and this is a procedure we can use to get rid of the square root. What we're going to do is multiply it by the conjugate. Okay, so we've done this, you guys have all done this in 11 minutes when we were talking about surds. If we have A take B, all right, if that's a term that we have, then the conjugate of it is A plus B. All right, it's the same, but we change the symbol on the inside. All right, so I'm going to get my red marker to show you. So we're going to multiply this one by all right, so we're not changing the value of it. We're not doing anything illegal. Over here, this and this are the same, so that divided by that equals 1. We're multiplying it by 1, there's one lot of it, we're not changing its value. So that's a legitimate operation. And the reason this is clever, right, when we have the conjugate, is when we multiply conjugates of one another, if we have A take B times A plus B, who can remember what this expansion is called?
Perfect squares.
Yeah, difference of two squares, this one. And this goes from A squared take B squared. And A squared is going to be a square root squared. It gets rid of the square root, so that's how we're going to do it. Okay, you can see here, A take B times A plus B. All right, it's going to go to A squared take B squared. All right. So, in our next step, what we've got here is we're multiplying fractions, right? And whenever we're multiplying fractions, it's just the top times the top and the bottom times the bottom. So at the top, I'm going to write out what we've got. We've got root x plus h squared, take root x squared. Okay, so the top times the top, A take B times A plus B gives us A squared take B squared. And at the bottom we've got H times, it's times both of those, so I need to put that part in brackets. Okay, so now let's perform the square, and that's going to get rid of the square root. We can collect like terms at the top. So we've got x, take away x. Okay, here h is a common product to the top and the bottom. When we cancel h, okay, it's not that it goes to 0. What we have at the top is h times 1. And so what we'll be left with is the limit as h approaches 0 of 1 on top of the square root of x plus h plus the square root of x. Okay, so you can see those steps still, all right? We've substituted into the formula, we've expanded, we've collected like terms, we've cancelled h. Now we're ready to apply the limit, and so we're substituting 0 where the h is. What does that leave us with? 1 on root x plus root x. Okay? Root x plus root x, they're like terms. If we have one lot of root x plus another lot of root x, we have 2 lots of root x. Excellent, okay? So, for any first principles problems involving roots, we need to multiply by the conjugate, okay? Wonderful. All right, I'll spin this one around so we can do the next one together, which is 5 on x squared, 3 on x squared. Okay, so something like that, right? You know, you go, there's no way I know how to do that, and you're absolutely right, same, okay? That is something that, now that I've taught you, now you know how to do first principles involving roots. So it's not something we would surprise you with. That would be very nasty. All right, so we've got f of x is 3 on x squared. F of x plus h is going to be 3 on x plus h squared. Okay, so let's put in the formula. Okay. So for these kind of ones, right, when we have a fraction, okay, when we have a fraction, f of x is a fraction, we need to smash that fraction together. We want to make it one fraction. And so in order to perform this operation, this one take away this one, fractions need to have the same denominator. Okay, they have to have the same denominator. So we're going to cross multiply the denominators here to make them have the same denominator. So we're going to multiply this one by this denominator, x squared on x squared. So we're not changing its value, x squared on x squared is 1. And we're going to multiply this one by x plus h squared on x plus h squared. Okay, which is also 1. We're not changing its value either. So over the next few steps, I'm going to draw it out nice and slowly and show you guys what's going on here. Okay, so all I've done, I've shown the cross multiplication there, and then in this next step, I've multiplied this fraction now. Okay, that's given us that. And this fraction here gives us this term. Okay? And what we can see now is that they have the same denominator. So that means we can bring them together. Alright, so what we're doing in the next step, if you have 3 on 4, take 2 on 4. Okay? They have the same denominator. You're looking at that going, oh, that's 1 on 4. But what it simplifies to first is 3 take 2 on 4. Because they have the same denominator, you can bring it together. And of course, 3 take 2 is 1. That's what we're doing here. We have the same denominator, so we can bring it together. Alright? Okay, which is on top of h, and h by itself is on top of 1, isn't it? You know, h just hanging out there, h divided by 1 is h. And now we've got 4 layers to the fraction, we can bring that to make 2. We've got AD on BC. Alright, so what that part will simplify to, I'll come down, because then I might come back up here in a sec. The limit as h approaches 0, 3x squared, so if that was a bit of a dodgy step, put a mark there and let me know as I'm coming around. But I've just moved from A on B on C on D to AD on BC. So effectively just moving the H there. Okay, now we're ready to just perform that first principles process. That is to expand, collect like terms, factorise and cancel H and apply the limit. Okay? So this is the tricky part, isn't it? Getting it to a stage where we can perform the first principles process. So let's carry on up here. All right. Okay, so I did the expansion in 2 steps because there was an exponent and a factor out the front that needed to distribute. Three x squared will cancel. We will factorise h and cancel it. Alright, and then we can apply the limit. We're substituting 0 where the h is. So that term's going to 0, so is that part. Let's write what we will have. Minus 6x on x squared times x squared, and we can just simplify this index laws. Alright, so that's a hard one. So we've got an opportunity to get into it and have a bit of a go at it ourselves. This is exercise 2A of our textbook. Now don't worry about question 2A and B yet. We'll talk about them at the end of the lesson because they are so simple that people often stumble over them. Like question 1 and 3 you can get onto. And there are some extra problems here as well. But you did see the difficulty really escalate from how we started doing it in year 11. Excellent. Any questions? Wonderful.